What's up, everybody? Welcome to Earth Science. So, if you were absent on today, the 17th, Wednesday, this is the lab we did. Um, and it's significantly stripped back from the way that I used to do this. The old lab was everybody would draw station models on all of these circles and then we'd analyze it. I got rid of 85% of the work, but I need you to really kind of focus on the last 15%, which is going to deal with how mid latitude cyclones work around low pressure systems. All right. Now, if that sounds scary and confusing, this is really going to rely on you having your cheat sheet ready to go. So if you don't have that, find it. I've got spare copies. You can start it over again. I'll include the videos and the email that I send for you guys. You need that. I mean, it'd be very difficult to do this without it. And what it's going to be is basically you take what you've drawn this whole thing, if you were here in class or if you did it when I send you the email because you were absent that day. You've got everything on here you need. You've got some of that on here on this map. And your job is going to be like, okay, if this is where the low is, and I see thunderstorm, hail, thunderstorm. In other words, there's a line of storms right down through here. And I see showers up here. Where does that mid-latitude cyclone go? I mean, the low's already there. So that's there. That's there. Now, where do the fronts and the air masses and the wind directions and all of that you've already drawn on this thing, where do they belong? I've given you part of the picture. You got to finish the picture off of your cheat sheets. With the goal of seeing how these work. I mean, that's a mid-latitude cyclone there. That's a mid-latitude cyclone there. This is going to be another example of a mid-latitude cyclone. So, let's just back up and say, what the heck are these things? When you get low pressure, what happens is that it pulls air towards it. So this is not live. I went back a little bit because this thing was a little neater then. Here's a low pressure right up here, just northeast of Maine. I can see counterclockwise and inward winds, right? I'll zoom in a scotch. Okay. Cold air has been getting dragged down from Canada over that. And this is this morning. So you're home, but if you've stepped outside, you're realizing that it's pretty cold. We've had this blast of cold air come across the country. The weekend NFL games, if you watch any of that, were a lot of them had record cold. Simultaneously, you see these things going up here. There's warm air getting pulled up from the south. That's what these lows do. That's what a mid-latitude cyclone really is. Let's see. I don't know if I can draw on this or not. Let's find out. Looks like again. So I'd say there's my low. Again, that's given to you already on the map. You've got winds coming down like this. I should probably do them in blue because they're cold. Coming down from Canada. Right? And all of a sudden, right on that line, you can see where it stops. You can see a very distinct front. I mean, it's a front, right? It's the leading edge of where this cold air has made it. On the other side of that front, you're in the warmer air. So, I mean, I know, granted, I've done these for a long time and I can see that fairly easily. But that's your job. Using your cheat sheet. You don't have to know it in your head. You're going to use your cheat sheet and try to figure it out. Here's warm air coming up from the south. So how far has that warm air made it? And then again, off my cheat sheet, I remember that warm fronts kind of will be like this, approximately. This may not be perfect, but the one in your lab is simpler than the real life one we got going on in the East Coast right now. But that's about right. Back here's cold air coming down. Up over here's warm air coming up. And they're all trying to get counterclockwise around that low, which acts like a vacuum pulling air masses towards it. So you're given a simpler version of this. You got to figure it out. There's blue is cold. There's cold air coming down from Canada. Red is warm. There's warm air coming up. Can you figure out where the low and where the fronts would be? The fronts are the leading edge. They're where the air mass has pushed that far forward. That's your job. So in order, I'd go like this. This is the first thing you're going to do. Okay? Really, number one. You're going to study the map, look at it, look at your mid-latitude cyclone in your cheat sheet, and figure out where the fronts and everything else that list goes. Where's the cold front? Where's the warm front? The air masses and the arrows for where the wind directions are. Then once you got your map, you can say, okay, if I live in these 4 cities and I'm a TV meteorologist, what am I saying is going to happen? Look at your map and say, oh yeah, in Little Rock, it's like this right now, but over the next day, as this thing moves forward, because remember, they want to go around this counterclockwise, and don't draw this arrow, please. This low is going that way in general because of the wind belt that it lives in. So as this thing sweeps forward, what's it going to look like in the different cities that I picked there? Okay. Regions questions. We haven't done much with occluded fronts. Hint, hint. That's an occluded front right there. Occluded means that the cold front has run right into the warm front. So that's that scenario. They don't come up a ton on the regions. The other ones are the bigger ones. Use your cheat sheet to figure out what those two are. More mid-latitude cyclones and what happens. More station model interpretation. All stuff we've done a lot of. Okay, it may feel like a lot, but again, if you really over rely on that cheat sheet, it's going to get you to where you got to be. Okay, please get that done as soon as possible, and we'll move on with this unit and be happy. Hope you're doing well. Talk to you soon.